Hey, what's up, everyone? Today is January 16th, 25. It's another day for Leetcode. And we're not doing too bad this month. So it is kind of cold in here. I haven't even turned on my heater at all. So let's see what cold fingers are like for warming up my fingers. Okay. Yeah, definitely a little slower today than previous days. Let's go ahead and check out the problem of the day. 2683 neighboring Bitwise XOR. Huh, another XOR problem. I just haven't seemed to have solved this one yet. A zero indexed array derived with length n is derived by computing the bitwise XOR of adjacent values in a binary array original of length n. Um, so we're given a derived array. Specifically, for each index I in the range 0 to n minus 1, if I equals n minus 1, so if it's the end, then derived I equals original I XOR x0. Otherwise, derived I equals derived I XOR derived I x or I plus 1. Given an array derived, your task is to determine whether there exists a valid binary array original that could be formed derived. Return true if such an array exists, or false otherwise. A binary array is an array containing zeros and ones. Hmm. So derived can be either 1 or 0. Hmm. One, 1, 0. Is it possible? Give me a minute. I'm just thinking about this. No matter how many times this is shifted, that's one. This can be 10 to the 5. Oh man, I don't know how to solve this off the top of my head right now. Hmm. Zero, 1, 0 is what? It doesn't really, the examples don't really help me think of a solution though. If you're trying to achieve one, but it has to be a rotation of it, right? So if you have something like, I don't know, 1, 1, 1, 0. Is this valid? If we have 1, no, 0. No, this wouldn't work because if you had 0, 1, 1, 1, and you rotated it to 1, 1, 1, 0, would this not work at all? I feel like this would be false. I feel like a running 3 bits might never not work. Because this would be a 0, because this would turn into 1, 0, 0, 1. So we want the first value to be, okay, this would become this, which would make them all 1s. That's not what we want. So how can we change this value? If I made this 1 instead, it would make this 1, which would make this 0. But it would also make this 0. Okay, so for any value or any bit that is a 1, you have to have 1 bit from you or your neighbor be a 1, and the other neighbor be a 0. So if you have 3 1s, I don't think it's possible. If you have 2 running 1s, I feel like it's possible. If you have 1, it would be, no, that wouldn't work either. Is it odd number of 1s? If you have, no, because if you have 3 1s, it wouldn't be possible, right? Or no, what if you had 4 1s? Four ones. 4 1s is possible. If I do 1 1 0 and 0, because this would be what? 0 1 0 1, which would be 1 1 1 1. So the bits that are rotated would be possible if there's an even run. So you're telling me if you have an odd number of runs, so int running equals 0. If derived I equals, was it 1, running plus plus, else once we hit a 0, if running mod 2 not equal 0, return false. I don't know if that would work, but so we go 1, then you find a 0. If it is odd, return false, set running to 0. And then you keep doing that over and over again. Yeah. And then if it climbs off the end, the same thing, right? If running mod 2 does not equal 0, return false. Otherwise, return true. If there's no run, if all the runs are 0, this is just my first thought. I mean, it works for these. I'm not sure if it works for everything though. I don't know why I did that. I could have just did else if, but whatever. I don't think this is gonna. Yeah. 101. Wow, past 700 test cases though. Let's see. Expected true. Oh, wait, hold on. This works because if this and this is even, it's fine. It's like a sliding window, right? So how would I do the reverse? Okay. We need to first detect our first 0 is the thing. Right. Else, if wait, if it's a true, if first 0, this, let's do this. Okay, if first we want to check the end. Okay, so we did this till we found a 0. If it is the first 0, then we count the other end. Wait. Hold on. The running only counts for the first 2 bits, right? Hold on. So this 1 is going to go to the end, right? But this one's going to be here. So how is that going to contribute? If I think I'm going to have to check both the beginning and the end. If derived size plus 1, then running plus. Yeah. So if we just do this, and then we don't really need an else. We can have it set to both. Right? That's not what I wanted to do. Oy vey. So there's a 1 on the end. But there's also an even number, right? So 0. Oof. Maybe it's not what I think it is. This would technically be an even count of 1s. But there's no value, or no, there is a value that does it. Wait, why am I returning false if it's even? Oh. If I equals 0, wait, Vay. I feel like I'm in the wrong direction. Kind of, because a lot of test cases pass. Makes me wonder what the other test cases were. All ones wouldn't work. Or no, all ones would work. I'm not seeing the logic behind it. You know evens work because you can have a 0, 1, and then if you do it by the neighbors, it will be 1, 0. But that doesn't work for the edges. Because the edge on the left is going to be the value on the right. Alright, let's look at a hint. Understand that from the original element, we are using each element twice to construct the derived array. From the original element, we are using each element twice. That doesn't help me. The XOR sum of the derived array should be 0, since there is always a duplicate occurrence of each element. Isn't that the answer? Wait, so if you XOR everything, those go away, this becomes 0, this is 0. You're saying that's true. This 0's out, this is 0. This 0's out, this doesn't. Because there's always a duplicate occurrence of each element. Oh my goodness, I see it now. So instead of dealing with the edge cases, the shifting over or whatever, they're just they're just XORing everything because the duplicates are going to cancel out. And if it's even, it's always going to be 0. Well, that's kind of annoying. And then that takes care of all the edge cases. Oh, I don't like that, though. That's... You're telling me that's it? I mean, we had the running logic, right? Because we were running through and we're like, okay, if it's even, we know it's valid because you can make them by shifting over two values and then have 0, 1, 0, 1 be 1, 0, 1, 0, and those make 1. And you know that you can't make odds. And by doing it this way, I guess it makes sense because they've eliminated all the even values. I mean, okay. Let's go ahead and not copy stuff over. I think that hint gave it away too much, though. But still, it used my logic that I was thinking of anyway. But I gotta remember that what exactly XORs do. Okay, well, that was the problem of the day. Thank you for joining with me and seeing what I was doing. I kind of failed this one, but still a good problem. I hope you have a wonderful day. Later. Peace.